example, this time I'm using the wave function to represent a displacement, and displacement as a vector quantity is often represented with the letter s. So s this time is the function. Again, it's time dependent, so this time we're talking about the displacement of something in the y direction, say if it's rotating. How far has it moved along some sort of track or channel? 15. So now we know the radius of rotation, the maximum distance this thing can move is 15, say, centimeters. We've got an angular velocity of 1.7 radians per second, and it starts at an angular phase angle of 0.2. So in other words, this is not starting at 0. That would be if I was 0. What's happening is, at the start point, I'm already at an angle of 0.2, so I'm up here somewhere. In this case, we say it's leading in this situation. In other words, it's already started, it's leading. If I look at time 0 as being here, it's already moved to this point, so it actually started sometime earlier. So whatever is happening here, it started before, it's leading it, we say. So at time 0, it's already at this point, and then time goes by. What I want to know is the time it takes for this thing to reach maximum displacement. So what do I do in that situation? I want to find the time. I don't know this, but I want to know the time to reach the maximum displacement. So what's the first thing I think to myself? What is the maximum displacement? Maximum displacement is 15. It tells me that here. That point is 15. So I want to know the time to reach this point here. What is the time to reach that? So I can instantly write down that this is 15. And if I divide both sides by 15, I'll get 15 over 15 is 1. So in other words, in this case, 15 equals 15 sine omega, which is 1.7, times the time, which we're after, plus 0.2. Now if I divide both sides by 15, I get 1 equals sine to the minus 1, 1.7t plus 0.2. So now I'll pause this. I want you to carry on, think about the last example we did, and try and find out that time, the time it takes for it to reach maximum displacement. And I'll just pause this here and we'll have a look. Yeah, I'm thinking about a later step, aren't we? So it's just sine, still just sine. Sorry about that. Hopefully you got that answer. In questions like this, if I'm after the maximum, the time for the maximum displacement, or the maximum displacements involved, if you think about it, 15 in this case, these are always going to be the same, which means this is always going to be 1, of course. So in questions like this, you're always going to end up with the inverse sine, sine to the minus 1 of 1. Okay, I'll stop that there.